Hi guys, so I'm continuing on my video, and yesterday we developed a Perl based exploit, and we exploited a vulnerable server using buffer overflow that the series of tutorials that we have been watching for quite a long time. I started there, and today I will quickly show you how to create a Metasploit module. Now, in fact, making Metasploit module is kind of a secondary part of exploit development. Exploit development mostly revolves around understanding assembly and then fuzzing and seeing the EIP override and stuff like that in a debugger. So Metasploit comes much later point. Even if you don't know Metasploit, it's okay. If you are good in Python or stuff like that, it's fine. You can still be able to hack as many systems as you wish. No one can stop you. But still, since Metasploit is a mature product and it has ton of exploits in that, it could scan for vulnerabilities and exploit. It could be automated, so it wouldn't harm to learn Metasploit as well. So I have my Windows machine here, and I have installed Metasploit in this itself. So for me, it sounds ridiculous to have one separate operating system just for attacking a particular system. The thing with hacking is to make a program do something which it is not intended to do. That's what's hacking. It doesn't mean that you have to have 50 or 50,000 operating systems and then you're hacking from a Mac through Linux using Tor. Those are just circus. If you know the concepts, if you understand what an exploit is, what a vulnerability is, end of story, right? End of story. So anyway, just for the fun, doesn't hurt if we learn something cool. So I have gone ahead and installed Metasploit, so I'll quickly kick in that. So CMD, and it's basically same in Windows. Metasploit framework is little rusty, it's little slow, but it works. MSF Metasploit framework console. So the process to convert a Perl exploit into Metasploit module or a Metasploit exploit, here we are talking about developing a exploit which runs in Metasploit. It's not that we are just searching for some of the exploits and running that. So there is a process how we get that. So using a debugger, and there's a we have a very awesome debugger called Immunity Debugger, and we have a very good plugin called Mona. We can get a template, and let me quickly show you how that looks like. So if I have, so using those plugins, this is, I had been studying the ASLR, so stuff like that. If you do not know what we are doing, so I request you to go back and watch that, and we have already done the evasion of ASLR, and there are multiple ways to do that. So we covered that in a previous video, so you see that, otherwise this stuff wouldn't make any sense. So uh, let me open the immunity first of all. Let me show you, because we already have the Perl exploit here written, so how different the Metasploit module is. So let's see that. So in order to generate a Metasploit exploit, you just go ahead and type Mona skeleton, and then it will ask what type of skeleton you're looking for. Of course, we are having, what we have here is a web server, so it's TCP communication, and the file generated is msf skeleton.rb. So it's hard to find that, so usually there is not a specific place that it is usually located. So previously it used to be put inside the Immunity debugger itself. Now it's somewhere else. So if you do not find that, just go ahead and hit that in search. It would take a couple of seconds and you would know that directory. Now since we have found that, so I will go ahead and open file location. So it will be in a weird place like this. But once you know the location, Do not need to come here all the time, by the way. Once you have the skeleton, there are three skeletons only: file based, and this is TCP based, and there is UDP based. That's all Mona does. So you take that. Now I will delete this file because I have already taken that. Keep it in the desktop. Let's close this debugger. We don't need that now. So let me open the exploit here. The Perl exploit is already there, so let me open that Ruby one also side by side, and we will do a comparison. So this is pretty much the skeleton. I'm not doing much here, so only the parts that we need to concentrate is these are the purple ones. So these are the bad characters, which means 00 and 0A, 0D. These are the characters which the functions like stir copy and those stuff, they would think that is a null terminator and it would stop this shellcode from executing. The next is disable knobs. Of course, we want knobs to be there because we do not know where the exactly our stack is located, even though we jump to the first 4 bytes of the stack, which is the memory location. But it could be a little bit here and there. So we have knobs over there, so that no operation for a while and then jump to our shellcode. And finally, our return address. This we calculated by a lot of effort yesterday. Not a lot of effort. We used Mona plugin again. That saved us. So that's the one. 2006. That's the offset, and that's the minimum number of A's or minimum number of buffer. The buffer size, or what can I say? The data we need to provide just before we override the EIP. Got it? So we pass random data, and it is 2006. It would be probably 2006 bytes, and then here we pass 4 bytes. So that's what we do. Probably it's not 2006 bytes. Let me think about that. Alphabetical A we are passing, and alphabetical A is written in ASCII as 97, which is in hex is 41. So theoretically 2006 is actually the number of bytes that we are passing before we run to override EIP. And then finally we pass the return address that we calculated yesterday, and then we pass our shell code. So that's what we are doing here. And this is FTP command, so this is true, and then after that only we are able to pass our buffer and then the return address, and here we have knobs, and then here is our shell code. So in Ruby it looks a little bit different, but basically the concept is same. Here is true and then pattern create 2006. What it does is if we pass simply the A's, and if because this is a web server, so it's the data is going from a client machine, the attack machine, to a victim machine. So what could happen is, suppose if there is a protection mechanism, like there is an intrusion detection system, so it would drop the packet. Lot many A's, it doesn't look like that it's a valid input, doesn't it? So using Metasploit we have some utilities, and we can randomize those stuff so that to the intrusion detection system it would look like normal packets. And here we are doing a pack function and then passing v. Basically what it does is it swaps the bytes, it just flips the bytes, because the memory the addresses in the memory are in Little Indian, so but the processor always executes them in bytes, in bits, so it needs to be flipped, because RAM could be of any stuff. It could be following Little Indian, Big Indian, doesn't matter. The processor will always execute bits. So it means we need to be able to reverse these values. So that's what it does. It converts this thing into normal form. Like this value we got from the address, and that is in Little Indian, but processor wouldn't know that. So we have to flip that. That's what's exactly happening here. And then our knobs, and then our payload means it would be the shell code. Like we had calc.exe yesterday, and then today we will have something more funny. So let's see. So finally, when the exploit is there, where do we put it? So to put it, first of all, you need to make sure that you have downloaded Metasploit framework, not Metasploit community, not Metasploit Pro, but the framework. That's what you need. Otherwise it wouldn't work. And then I have installed it in Windows, Metasploit framework, and then you go to embedded, and then here is the framework. This is the actual stuff, and then here are the modules. These are the modules and exploit, and then Windows, and inside I have made one directory, that's my directory, and here I have put the exploit. So if I open that, it's exactly the same, doesn't it? So that way Metasploit, the MSF console, would be able to locate this exploit. So now the console is running. So let's start our vulnerable server and let's exploit that. I'll put shift right click, vulnerable server, and exe vulnerable server is running, and we come over here and we type use exploit Windows, and because I have only one exploit, so it's able to find that. Let me make it a little bit bigger and show options. By the way, I am able to type that much fast because I touch type. So if you want to increase your typing speed, there are very good softwares out there. So just Google it, you'll find it. It's not like I am a pro in this. I do a lot of vulnerability research and assembly language and reverse engineering, but I do not use Metasploit a lot. So these are the options. So what we need to do is we need to set lhost, because we are running locally, so it will be 127.0.0.1. We need to set remote host also, that is again 127.0.0.1. And let's see what we got here. Okay, so our R host and our port are set, and let's choose our exploit. So the command to do that is set payload. So it takes a little while because it has to search through a lot of things. Let's launch the interpreter and reverse TCP. So now we have set the payload and we exploit. So boom. So even though nothing is happening, but if ideally it would have been, if this the terminal on the right side would have been in a Linux machine, you would see the magic. So you would see something like execute -f. This is the way to run some commands. Suppose I want to open notepad -i-h. So probably it's it's not able to come into the foreground. Let's try something else. Execute -f calc.exe-i-h, and here it is. And not only that, since we have control over the process, we can terminate that as well. Yes. So it's a little shaky, but what's going on is we have absolute control over that. And let's see what else we can do. Execute ms word.exe. Let's see what I have here. I'm sure you got the point, but still, just for the fun of it, I'm doing that. Or probably let's stop here. It doesn't matter, right? Doesn't matter. Also, we can get into the shell program also, like cmd.exe-i-h. So we would be in the command prompt, and from here also we can do all sorts of stuff. So like we open the notepad, right? So we can exit from there and then terminate the channel. Now we are again inside Meterpreter. So it would look a lot fun if it would have been different OS, but the point is it works and the same concepts would be applied. So if you run these commands exactly like what I did, and you just paste that exploit file in exactly this location, the output would be exactly the same. And you, as you can see, the program is still running. It doesn't have any goddamn idea that some another process has taken control over it. So that's the fun part. So thank you guys, and I think I'm done now. And moving forward, we would be working heavily on bypassing the exploitation mitigations. We have covered ASLR, so my next target would be DP, then stack cookies, then SEH, structured exception handler, and many other stuff. And with Windows 10, we are going to see lot many other stuff also. There is a hypervisor model over there. They are bringing cloud technology to client machine for protection mechanism. Let's see how that goes, and stay up to date and hack your systems before someone else does, because a pen tester has all the legal permission to secure a system, so it's his responsibility. So learn as much as you can and subscribe to this channel. I will keep making these videos, and if you want me to cover a specific topic, you can suggest me that, and I would make video on that. So I thank you guys, and have a good day. Bye bye.